Okay, so next up is probability of independent events, and these are relatively straightforward. If it's an independent event, then they happen separately. The first event doesn't have any relevance on the outcome of the second event. Okay, so you're calculating the probability separately and then you're multiplying them together. So in this case, a bag contains 4 red discs and 6 blue discs. A disc is drawn at random and it is not replaced. Okay, so just be careful about how the questions are worded, because if it is replaced, then in each case you have 10 discs. Okay, and so the probability of the first one absolutely doesn't affect the probability of the next at all. Okay, in this case, both discs are red. Okay, so if both discs are red, you've got 4 out of 10 the first time, and the second time, you've only got 3 red discs left out of 9. Okay, so there is 2 out of 15. Okay, so the two probabilities, this is the first probability, your second probability then is 3 over 9, multiply them together. The first is blue and the second is red. Okay, so the first is blue, there will be 6 out of 10 blue discs. And the second is red, there are 4, but there's only 9 discs left. Okay, so 4 out of 15. The first is red and the second is blue. So if the first is red, you've got 4 out of 10. And the second is blue. So you got 6 out of 9, which again gives you 4 out of 15. Remember, you're multiplying fractions, so 4 by 6 and 10 by 9, no matter the order, is always going to be the same, equate to the same number anyway. Both discs are blue. So we have 6 out of 10, and then you've got 5 out of 9. And we've got 1/3. Both discs are the same colour, so they are either both red or they are both blue. Okay, so if they're both red, we have up here both red, that is 2 out of 15. So we've already calculated that probability in I. And if they're both blue, we've got that probability to be 1/3. So the probability that both discs are the same colour, 7 over 15. Okay. Okay, a fair dice is thrown 3 times. Find the probability that there will be. So this is probably more straightforward of an independent event, because I'm not taking discs out. Literally, if I throw the dice, I can get the same answer. I could possibly get the same answer every single time. Okay, a fair dice is thrown 3 times. Find the probability that there will be no 6s. So if there's no 6s, there are 5 other choices out of 6 it could be. And remember that I'm doing this 3 times. So 5 out of 6 on the first, times 5 out of 6 on the second, times 5 out of 6 on the third throw. That would be 125 out of 216 is the probability that no 6s are thrown. Okay, the probability that at least 1 6. Okay, remember, when we have a probability of at least 1, it's 1 minus the probability of none. Okay, so we did that before the Christmas break in class. So 1 minus none. So the probability of no 6s is here. So 1 minus 125 over 216. Okay, because the probability that there's at least 1 has to be the exact opposite to there being probability of there being absolutely none. So the probability that there is at least 1 6 is 200. And at least 1 6 is 91 over 216. Okay, and the probability that there is exactly 1 6 Okay, now there is exactly 1 6. I can have a 6 on the first throw. So that's 1 over 6. And if it's a 6 on the first throw, that means the second throw can't be a 6. And the third throw can't be a 6. Okay, now I could also have that it is not a 6 on the first throw. It is a 6 on the second throw, and it's not a 6 again on the third throw. Or I could have, it's not a 6 on the first, it's not a 6 on the second, but it is a 6 on the third. Now, every single probability here that I calculate, okay, will get me, go to my calculator, will get me 1 over 6 times 5 over 6 times 5 over 6 will get me 25 over 216. Okay, because I'm multiplying the same numbers. And remember, multiplication doesn't depend on the order that they're multiplied in. Okay, so I've got each of these. Or means to add them. Okay, alternatively, without having to go and actually list them every time, I know that it's the same probabilities, I'm just changing the order. I could have just multiplied the first one by 3, and I would have got 25 over 72. Okay, alternatively, I can add them all, and I'll still get 25 over 72. Okay, last question says, find also the probability that the 3 throws all throw the same number. Okay, so if they all throw the same number, so for example, if they all throw the number 1, okay, that would be 1 over 6 times 1 over 6 times 1 over 6, which is 1 over 126. Okay, now I can do that for the number 1. For the number 2, it's going to be 1 over 6 times 1 over 6 times 1 over 6 again. For the number 3, it will be the same probability. For the number 4, it will be the same probability, and so on. So it will be 1 over 126 for each of the 6 numbers, which will give me 1 over 36 chance of throwing the same number.